Are we on? We're cooking? I am a frustrated actor, I'm telling you. Okay. Can you hear me?
Yes.
Are you all right out there? Okay. This is going to be the Gumdrop Lab. You're wondering, I'm using clay, why am I calling it a Gumdrop Lab? Well, years ago when I first came up with the lab, a buddy of mine and I decided to, take it on the road. We went to like state conferences and we showed it to people. That was back in the 80s. So we used to use gumdrops and marshmallows. And the kids get these sugar highs, okay? And I've kind of gotten away from that because the gumdrops get a little yucky, by the time the lab's over. So I use clay balls. So I have clay, I have three kinds of clay. Okay? So what we'll say today, I'm just going to use oxygen is red and hydrogen is yellow. Now, first thing to know when you're doing this lab, please don't mix the colors, okay? That's important. Thank you. This is a ball of clay. So when you do this, we don't have enough clay for everybody to have their own color. So take the color that you need, all right? Now, you'll see if you go to the sheet at the end, this says, let's go through this quickly, the lab. The first page gives you a little bit of a background on it, yes? And then you talk about the position of the lesson in the unit of bonding. Now remember, we started bonding actually back when we were doing quantitative quantum numbers, didn't we? Even atomic structure. Because we were always saying, because people ask me, well, what's the difference between an atom in its ground state and an atom in its reacted state? Why do you even have a ground state? Is that because how many people, raise your hand, thought that the ground state was actually a stable state? Ground, stable. Yeah, you ground an electrical wire, it's stable. Wrong. Ground state is the unreacted state. So it's not stable. The ion form is the actual stable state. For instance, sodium has 11 protons and 11 electrons in the stable state, correct?
Yeah.
Okay. However, in the ground state. But it's not stable. Why? Because its valence shell is not like a noble gas. It loses an electron, and it has a valence shell like neon, then it's stable. And it's an ion, because it has 11 protons and only 10 electrons. So when they bind with each other, then they're stable. Yes? Yes? Now, strictly speaking, covalent compounds, molecular compounds, what this lab is based on, don't have charges because they're covalently bonded. But the oxidation state gives you an idea of how many, it has you make sense of how many of each atom you may have with each other atom when they bind together, correct? So we started talking about bonding back in chapter 4 and 5, mainly ionic bonding, right? Covalent bonding, we started to get into relative to sharing because when we looked at electronegativity, or the ability of an atom to attract electrons, bonded electrons, then we had to all of a sudden talk about covalent bonding. All right, so this is the deal. And if you look at part one of this, I did yesterday, correct? Now, there's also part 1, 2, and 3 in the playlist of rebonding that's from last year. Okay? I put a playlist on bonding together, much of which revolves around this Lab. Specifically molecular, what does it say? Can you please access the playlist, somebody? And read to me the titles of the videos in the playlist, just very quickly. Anybody? Yes. Oh, here they are right here. Thank you very much. Okay. So we have, here's the playlist. I have 9 videos. Actually, there'll be a few more videos in there. It says Molecular Geometry, Part 1, 2, and 3. The playlist automatically came up to Part 3. Okay. So, and I can see I have an NH3 on the board, and I'm doing, and I have now a beryllium hydride on the board. So that's going over. That's also a 3 video pre-lab. Yes. So I have a bunch of videos, and they are. Oh, here it is. Molecular Geometry Part 3, Part 2, Part 1 from last year. Bonding Part 1, Part 2 from last year. These are all last year. Test Review Ionic Metallic and Covalent Bonding Part 1 and 2. Bonding, wait a second. Bonding Part 1 and Part 2. Did I say that already? Did I say that? Test Review Part 1 and Part 2. Bonding Intro. And then it just says there's one on bonding. Oh, I know what that is. I should rename that. That's the lecture from the book, the one that says bonding. It has radon on the front picture with some blue lights. That's radon. That's a 3-hour and 16-minute complete and absolute lecture that you will not look at in one sitting, or you may turn into a bowl of Jell-O and cease to exist. So you don't want to do that. That would be dangerous. So I also have a couple more that I'm going to put in a playlist that I've made. Yes? Thank you, Solomon. Okay, so I'm going to do this in several different ways. Okay? Now, if you look at the different shapes, A through J, okay? A through J, okay? It says linear, angular, trigonal planar, trigonal pyramidal, tetrahedral, square planar, seesaw T, trigonal bipyramidal, and square base bipyramidal. A through J. Do you see that? Everybody? Okay. So, that's that. Now, then you talk about the steps for arranging the molecules. Yes? And then it has a whole list of how to put them together specifically, and we're going to go through them very quickly. Okay? Yes? First one is linear, where I have 2. You know what I'm going to be doing? I'm not going to do oxygen and hydrogen. I'm just going to do models. I'm just going to show you how to do models. Okay? Okay? Tell me when you've had enough. When you get it, okay? So I can quit this, because there's other things I want to do. Because you're kind of staring at me like I'm the alien. Okay. So here is an atom. I'm doing number 1 linear, right? So that's it. Even though I have it like this, where this is a bond, and it's understood that there's an atom here. Yes? Yes? You see that? Yes. But I'm going to make it look like that. Okay? So it's the same thing. So the first one, linear, where it says bonded pairs, non-bonded pairs. I'll explain what that means in a minute. But anyway, you see where that toothpick is a bonded pair. Clear? So, in the first one, you obviously have to have 2 atoms, right? Yeah? So that's what it looks like. Yes? Clear? Linear. Straight line. Now, let's say I have 2 of the same atom, 2 hydrogens, because as you know, hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, etc. Did I forget one? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. When they're gaseous, they are diatomic. So this is what they look like. Okay? So that's the geometry. Yes? Linear. Now don't kid yourself. It's not going to look like this. It's going to, first of all, it's going to look probably more like this. Yes? You get it? Probably. Okay. So now, if I have linear, where I have three, I have a central atom, three total atoms, and I have two bonded pairs, and no unbonded pairs. Easy? Yes? Trigonal planar, three bonded pairs, no unbonded pair. Are you getting this? Are we getting this on film? Mm-hmm. What I'll do is I'll leave them. I'll just make the whole bunch of them and I'll leave them. Shall I leave them in just toothpicks? Is that okay? Yes? Yeah. Is that okay? Yeah. Just toothpicks? Okay. But you have to put the other atoms on, okay? So I'll just make a bunch of these, okay? This one was two atoms. This was two atoms, one bonded pair, right? That was number one. Somebody take a piece of paper and fold it in quarters, okay? And put on there linear, put the different things on, linear, etc. Make a list. Who's going to do that for me? Well, why doesn't it do this? 1, 2, 3, 4, 5, 6, 7, right? Character 7, right? 8, 9, 10, 11, 12, 13. So find out what number you are. We may not even have that many. I think we only have 10. So get a piece of paper and draw and fold it twice so it's in quarters, right? And then on it put your geometry. You're going to read down the list because these geometries are not numbered. And then what I'll do is I'll do a overhead of them on a desk. Okay? Clear? All right. If you have a question what that means, ask me. Okay? Now this geometry was like this, right? Yes? That was linear. Now, what's the fourth one? The fourth one is bent, right? Bent. Yes? Okay. Now, bent is the first one. I'm going to use a big central atom. The bent is where you have one non-bonded pair, right? So what does that mean? So bent looks like this. Here's the bonded pairs, okay? Yes? Not 90 degrees, but you can look all that up in the book. It doesn't have to be perfect, okay? And then the unbonded pair is you have to take years ago when we were kids, we'd call these pipe cleaners. They were shorter than this, maybe this big. Yes? They're called pipe cleaners. And men who, God, you always saw pipes. I had teachers when I was in high school, that smoked pipes right in class. Smoked cigarettes in class. Weird, in high school.
Doesn't tobacco fire like that?
They were not very sensitive, even if I don't even know if we had them in the class. I have no idea. Okay, so you cut these in quarters, and here is the non-bonded pair, and this one would be here. So they're going to be on the same plane if you're going to have three, right? Good? Not bad, huh? And you thought that I had no creativity. I heard you talking to Laura. Okay. Okay, you ready? What's next? What's next? Is anybody here? This is a very quiet class. This is my period, section 2. I think that there are only 3 native English speakers in this class. Angola, Brazil. You're native speaker, right?
Yeah.
Okay. UAE? UAE? Z-Man's UAE, man. I'll tell you, Z-Man. Okay. Spain? Jordan? Where you from?
Local.
You're local, UAE. No, don't tell me. Malaysia? Korea? US, right? Yeah. Korea? Belgium? Did I get that right? Excellent. Georgia? A state unto itself. Depends on who you ask and how long ago you asked them. Korea? I think the dominant heritage here is Korean. No? Is that mostly Koreans in here? Yeah, but I'd say a third. You think a third Korean? Yeah. Okay. All right. So that is what? What are we doing? Let's get back to it here. Wait a second. Hold on. What am I doing? Oh. Okay. Wait a second. Now this one's interesting. This is called Trigonal Pyramid, and these angles are all the same, right? This comes from actually this. See this? This was trigonal planar, right? Yes?
Yeah.
Correct? Did I do this already? I did, right? Right? Yeah. So that's the same thing, but what happens is this. So they all get a little bit pushed out. It's not a big thing. It's not like a giant pyramid. We're not talking about, a pyramid outside of Cairo here. We're talking about, literally, just a little hint of a pyramid. So this non-bonded pair is going to be above it. And what that's going to do is, that's going to force these out of the plane. See how these are all in the same plane? See that? Yes? This is going to, that shared electron business is going to force them out of that plane, yeah? A very, 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 very common geometry, substance. One of the most soluble gases that we know of right there. Okay? Now, what's next? Bent with 2 unbonded and 2 bonded, right? I know, you're very excited. You want to know which one that is because it's so dynamic looking. Now watch how I do this. I actually did this on film yesterday, so I'm going to tell everybody. So it's actually approximately 109, 107-ish, okay? 2 non-bonded pairs, okay? 2 non-bonded pairs. And they're going to be like, it's not like in the same plane. They're going to be out of the plane. I think of kind of like Mickey Mouse, ears, yeah. So these are all, if you look at these are in the same plane, sort of, right? These 2, right? And then these here are out of that plane. It's a little funky how to do this. I'll show you a trick on how to make this a little bit better. Show you a trick. Is that good? See that? Can you get that? Does that pick up, Laura?
Mm-hmm.
Good?
Yeah.
Yes?
Perfect.
Good. Excellent. Thank you. You're very encouraging. I should learn something from you, Laura. You're just very affirming,
Stop it. That's so cute.
Now, the next one, we're going to use a big central atom. Trigonal bipyramidal, okay? Trigonal bipyramidal. And that's going to be 5 bonds, okay? 5 bonds, but they're all bonded pairs. 5 bonded pairs, okay? And we're going to go like this. You're going to have 3 in the same plane, like this, right? 120 degrees. You all right with that? Is that good? Is that fine? Is that good? Yes? And then you're going to have on the top, exactly the top, and exactly the bottom. Right in the middle. So you literally have an axis. It's like an axis. Okay? See that? You with me? Excellent. Okay? So if you think of it, there's 3, 3-sided pyramid on top and a 3-sided pyramid on the bottom. Clear? This is trigonal bipyramidal. These are all in the book, where they should be. Aren't they in the book?
No.
Somebody take out chapter on covalent bonding and give me a high side on that. The next one is the seesaw. Now this is where you're going to get the seesaw from. Let me make that again, okay? These are in the same plane, right? And then I have 2. So we're going to go back to the trigonal bipyramidal. Okay? You see that? You see that? You with me? Right? You know what I just made now. If I take off one of the 3 that are in the same plane, if I take off one of the 3, see the 3 that are in the same plane? I take off one and I put in a non-bonded pair. You see how that's going to be a seesaw? See? It's going to look like this. See? Yes? So the fulcrum are going to be the 2 bonded pair that are at the angle and the straight. So it's going to be like that. So you literally, can you see this, Laura? Can you see this?
Yeah.
Okay, seesaw. See that?
Yeah.
Okay. So you're taking off one of them and you're putting on the non-bonded pair. Seesaw. Okay. Next. T. Same thing. Same thing. What I'm going to do is I'm going to say right. I'm going to make a big one. This is actually kind of slimy. Should I go on break here? Are you guys like losing your mind or what?
Almost.
Almost? How many more do we have anyway? Toggle down somebody. We're on T and then linear. Here, make yourself useful. Can you like make some balls of clay? Okay? Okay? Make a balls out of that, okay? So I want to do that again, T. Very good, Slom. Put them to work. Put the Z-man to work. Okay? Okay? I'm going to do this again. There's the trigonal bipyramid, right? And I'm going to say, right. Let's take off 2. Okay? Some teachers, they find this a very cute lab. And they end up doing it with middle school kids, and the middle school kids get so confused as to what these things are. So I go like this, and you want to take off two that are in the same plane relative to the three, right? So I'll take one off, right? That's one, okay? Then take another one off. And that's called a T. See that? That's called a T. Yes? T. Okay, now. All right. Now, next, instead of going through the whole thing, I'm going to take off all three where you have three in the same plane. And excellent. Thank you there, Z-Man. Salam. Excellent. Excellent. All right, here we go. You ready? This one's really cool. This one has to do with, I'll give you a hint. This one has to do with one of the few times that I know of, one of the few compounds that actually contains a noble gas. Yeah, isn't that weird? This particular geometry has to do with a compound where a noble gas bonds with a halogen. Isn't that weird? It's really weird. I know what you're saying. I know what you're saying. It's really weird. Well, you know what? It is. Okay, so we're going to take a break after this one. Is that okay? Because you guys are starting to, your eyes are glazing over. Okay? Okay? Cool? This is what? Linear, right? You get it? Okay. Laura, would you do the honors, please, and put that on stop?